Hey guys, welcome to the Conceptual Geometry Worksession 5.9 Virtual Key. First thing I'd like to draw your attention to is our formula sheet. You should have yours out as you do this work session. Remember, you can also use it on your upcoming exam. If you have been out and you've missed a few of the formulas, you can pause the video right here and copy down the formulas for midpoint and slope, including all my notes. All right, because that's going to be very important. And then you can pause the video again and copy down these formulas if they are missing from your formula sheet. Okay, let's get to the work session. Question number 1, what is the midpoint of this segment joining negative 6, 2 and 4, 6? So you're going to look at your midpoint formula on your formula sheet, and we're going to plug in the numbers. Remember, it's x plus x divided by 2. So I'll pick those x values, negative 6 plus 4 divided by 2, comma, the y plus y, which would be 2 plus 6 divided by 2. Negative 6 plus 4 is negative 2 divided by 2, negative 1. 2 plus 6 is 8 divided by 2 is 4. Negative 1, 4 is the correct answer, so that's choice 1. Okay, number 2. It says if the slope of a line is 7/3, what is the slope of a line perpendicular to this line? If you look on your formula sheet, perpendicular lines have opposite reciprocal slopes. So what we need to do is we need to take this slope here and negate it, so it would become negative, and take the reciprocal, so it's negative 3 over 7. Negative 3 over 7, that'd be choice 3. Question 3, which set of points would represent a line parallel to a line with a slope of 3? Well, parallel, if you remember, means equal slopes. And if my slope is 3, that means 3 over 1 or just 3. Now, there's no shortcut to do this. What we have to do is take every single choice and find the slope using our slope formula. So I'll start with choice 1. M equals, remember we do y minus y, and it doesn't matter what direction you go as long as you go the same direction for both. So I usually prefer to start with the bigger numbers. So y minus y in this case will be 3 minus 1 over 8 minus 2. 3 minus 1 is 2, 8 minus 2 is 6. So that's 1/3, clearly not equal to 3 over 1. Those are reciprocal, so it's not choice 1. Let's try choice 2. M equals, doesn't really matter which way you go, I'll go that way. Negative 3 minus 0 over 3 minus 4. Well, negative 3 minus 0 is negative 3. 3 minus 4 is negative 1. Remember, those negatives cancel, so that is 3 over 1, equal to my slope. That would be choice 2. All right, question 4. What is the center of a circle whose endpoints of the diameter are 2, 6 and negative 2, 4? Center is the same thing as midpoint. We're using our midpoint formula again. X plus x, 2 plus negative 2 divided by 2, comma, y plus y over 2, 6 plus 4 divided by 2. 2 plus a negative 2 is 0. 0 divided by anything is 0. 6 plus 4 is 10, divided by 2 is 5, so the center or the midpoint would be 0, 5. That's choice 4. All right, number 5 is probably the hardest one on this page. It says, what is the length? So I need to use my distance formula, and we're not on a grid, so we have to use, let me show you, the more challenging distance formula. That's this one right here. And that's if we have coordinates only, which we do in this case. It's x minus x squared plus y minus y squared. Then we take the square root of that whole thing. All right, so using that formula here, what I'll get is d equals square root, parentheses, 6 minus 2 squared, that's x minus x, plus 4 minus 1 squared, and that's y minus y. All right, so 6 minus 2 is 4. That's 4 squared plus 4 minus 1 is 3. That's 3 squared. 4 squared plus 3 squared is 25. So normally we would leave it here, but if you notice, that's not a choice. But sometimes the number that's underneath that radical is what we call a perfect square, and it allows us to take the square root. In this case, we can take the square root of 25, which is just plain 5. Choice 1 is the correct answer. All right, moving on to the second page. No more multiple choice. Now we have to show all of our work. It says the coordinates of A are negative 3, 2, and the coordinates of the midpoint of AB are negative 1, 5. So that is my midpoint. What are the coordinates of B? This is one of the rare problems in this unit where we don't use a formula. They're giving us the midpoint, so I don't need to use that formula, but remember the method here to solve this is to stack these coordinates. We put one endpoint on the top. The midpoint must go in the middle because it's midpoint. The other endpoint would go on the bottom, and when we find those coordinates, that would be the solution. So what happens here is we have to find the pattern with the x's. We went from a -3 to a -1, which means we added 2. So I need to do that again. Well, -1 plus 2 is +1. Next, do the same thing with the y's. I went from 2 to 5. That means I went up 3, added 3, add 3 again. 5 plus 3 is 8. So my solution is 1, 8. Question 7 says, find the slope of a line parallel to the line that contains 3, 2, and -1, -5. So remember again, parallel means equal slopes. So if it's parallel, it's going to have the same slope as the line that contains 3, 2, and -1, -5, which just means use your slope formula. Y minus y, I'll go this direction. 2 minus a -5, watch out for that negative, over 3 minus -1. So remember what happens here, those cancel, so I have 2 plus 5, which is 7. 3 plus 1, that's 4. You cannot simplify that at all, and that's my slope. Question 8, are the following set of points collinear? So again, what you need to do, if you look on your formula sheet, is look up collinear, and that means equal slopes. So I need to find the slope of AB and then compare it to the slope of BC. Well, AB, I'll subtract in that order. Y minus y, 8 minus 6 over 5 minus 2. Let's see, 8 minus 6 is 2, 5 minus 2 is 3. Can't simplify that at all, so I'll leave that. Next, let's find the slope of BC. So for this one, I'll go that way because 8 is the bigger number. Y minus y, 8 minus 4 over 5 minus -1. Watch out for that negative. 8 minus 4 is 4. 5 minus the -1 is actually 6. I can simplify that to 2/3. So what you notice here, those are equal. If those are equal, my points are collinear. So I'll say something like collinear because the slopes are equal. If these two are different, you would simply say not collinear because the slopes are not equal. All right, let's move on to some triangle proofs. We've done quite a few of these. This is kind of a nice one. It says, prove triangle ABC is a scalene triangle. That simply means no equal sides. We'll be using the distance formula on this 3 times. Start with the distance of CB. Doesn't really matter which one we do first. So here's CB. What we need to do is make our right triangle and count the sides. 1, 2, 3, 4. Delta y is 4. 1, 2, 3, 4, 5, 6. Delta x is 6. That'll be 6 squared plus 4 squared. 6 squared is 36. 4 squared is 16. Add those up and I get 52. So the length of that side is square root 52. Next, let's do CA. So this one's a little bit hard to see. That would be the length of CA. So this is 1. Delta x is 1. Delta y is 1, 2, 3, 4, 5, 6, 7, 8. I got 8 for that. So 1 squared plus 8 squared. 1 squared is 1. 8 squared is 64. 1 plus 64 is 65. So that length is square root 65. And the last one will be AB. So I want to find the length of this side right here. And make a right triangle. Delta x is 1, 2, 3, 4, 5. Delta y, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 5 squared plus 12 squared. Again, I expect you to put this into the calculator, but I'm just going to do it here. 25, 144. So that is square root 169. Now, what do you notice about all of these? Well, they're all different. All right, so I can say triangle ABC is scalene because it has no equal sides. All right, our next proof, a right triangle. This one's a little bit more challenging. Remember, to prove a triangle is right, we have to show that a squared plus b squared equals c squared, or leg squared plus leg squared equals hypotenuse squared. It looks like these are the two legs here, so I'll find those first. Again, I'm just using the distance formula. So distance of QR, square root, make our triangle here. So that's 1 and that's 3. 1 squared plus 3 squared, that one's pretty easy. 1 plus 9 ends up being square root 10. Distance of PQ, so that'd be this side, up and over. Delta y is 2, delta x 1, 2, 3, 4, 5, 6. So 6 squared plus 2 squared. Let's see, 6 squared is 36, 2 squared is 4, 36 plus 4 is 40. So that side is square root 40. And lastly, the distance from P to R. So make a triangle out of that one. That's 1, and we have 1, 2, 3, 4, 5, 6, 7. So 7 squared plus 1 squared. 7 squared is 49, 1 squared is 1. Add those together, you get 50. Now, in order for this to be a right triangle, leg squared plus leg squared has to equal hypotenuse squared. Here's how it works. You take the smallest leg, square root 10, and you square it. Plus the other leg, square root 40, and you square it. That has to equal the hypotenuse, square root 50, squared. And remember what happens here. The squared and the square root cancel out. So you're just left with what's underneath the square root, which ends up being 10 plus 40 equals 50. And indeed, 10 plus 40 does equal 50. So you get 50 equals 50, and you've proven that a squared plus b squared equals c squared. Now the conclusion would look something like this. Triangle PQR is right because you have to show me leg squared plus leg squared equals hypotenuse squared. So we use the names of the sides. QR squared plus PQ squared equals PR squared. All right, last question. This is kind of a neat one because it involves 3 different formulas with the same figure. If triangle SAD has vertices, S is -4, -3, A is 4, 1, and D is -2, 3. So here it is. A, I want you to find the coordinates of the midpoint of SA. You need to find that midpoint. Now, here are your options. You have a formula for midpoint. You can use these coordinates in the formula. But because you have a picture, you can tell me where you think that midpoint is going to be. Now, just by eyeballing it, I'm guessing it's going to be right here. But you have to verify, why is that the midpoint? It says label it out. Here's why, because look at your steps to get there. I have to go over and up, over 4, up 2. And then repeat that process to go to A, over 4, up 2. So that verifies to me that that is the midpoint, and the coordinates would be 0, -1. So that's all the work you would have to show, or like I said, you could plug into your midpoint formula, take the 2x coordinates, -4 plus 4 divided by 2, and the y coordinates, -3 plus 1 divided by 2, and guess what? You're going to get that same answer. Okay, next, the length of DS. So here's DS. I need to find its length. Well, we've been doing that quite a bit. That's pretty straightforward. That's going to be the distance formula. Square root. So delta x is 2, delta y is 1, 2, 3, 4, 5, 6. 2 squared plus 6 squared. We've actually done this already. 4 plus 36, square root 40. Done. That's it. Don't simplify that at all. And then finally, the slope of dA. So again, you do have a slope formula. You could use this, y2 minus y1 over x2 minus x1, and you could use the coordinates from D and A to do that. Or, here's how I prefer to do this. I think of slope as rise over run. And if I need to find the slope of this side, what I'm going to do is find the rise and the run. So I do this. The rise is 2, the run is 1, 2, 3, 4, 5, 6. Now, if you're going to be visual, you have to remember that a downhill slope is negative. All right, so it's going to be -2 over 6. I will give you full credit for that. Or if you want to simplify it, you may, but you don't have to, as -1/3. So by being visual, you would get the same result as if you used the formula. And again, you can use either method for all of these. As long as you come up with the correct final answers for all of these, you did it right. Okay, so that concludes the video key for the Unit 5 Day 9 work session. As usual, guys, if you have any questions, don't hesitate to reach out. Thanks for watching, and we'll see you in class.